YouTube stream on for this. মাইক কোনটা ইউজ করা হচ্ছে? ক্যামেরা তো হচ্ছে কি তো? হ্যালো। বলছে stream। একটু আসছে না কেন? না না এটা ওটা গিয়ে থাকে। বুঝছে অডিও আসছে না এটা ঠিক আছে মনে হচ্ছে ও So এগুলো ইউটিউবে ভিডিও করে হ্যাঁ এটাই। মানে একদম মানে লাইট বেশি আসছে না তখন আসছে আচ্ছা এখন তাহলে এটা এরকম হলে এটা ধরো তুমি কাটিয়ে দিয়ে দাও ওইটাই তাহলে পুরোটা ক্যান্সেল করবে স্ট্রেট হ্যাঁ চার্জ আছে তাহলে আগে সেটা বোধহয় বেশি ভালো হবে তাহলে একটু এগিয়ে এসো ভালোটা মানে মুখে পড়ে তো ওর জন্য এইখানে ঠিক আছে আমার ঠিক আছে ঠিক আছে আমরা দাঁড়াও শেয়ার করলাম
কিছুক্ষণ বাবা যখন বাবা কথা বলবে খালি শুনবো মন দিয়ে, ঠিক আছে? Okay, so let us start. Good afternoon, everyone. So today we have a very distinguished speaker amongst us, Dr. Tamoghna Ojha, who is an assistant professor in the Department of Mathematics and Computing at IIT ISM Dhanbad. And so the IEEE Kharagpur section, along with the IEEE Computer Society student branch of IEEE Kharagpur, we are very much happy to host this talk today. And the topic of the talk is next generation computing. And we are very much eager to hear from Dr. Tamoghna Ojha about what all changes are happening in the computing domain around the globe. So I would like to welcome Dr. Ojha to deliver his talk.
Thank you, sir, for the nice introduction. And obviously, it's my great pleasure to come back to the same place where I have, as a student, delivered maybe more than 10 lectures at different times. And it's kind of, I'm overwhelmed with joy. At that time, maybe, I had some other tensions, but now I have some different tensions. Okay, as the talk title goes, next generation computing. So as we all know, that computing as well as communication, so that goes through, as any other research topic, goes through immense changes at different times. So the next generation of computing, how it will be shaped, which are the major things which will change its focus in the upcoming few years. So all these things I will be discussing in a overview type of thing. So I'll be discussing all those points in this lecture. So I'll try to cover. So it will be kind of not so vertically, depth wise. I'll not be covering that much, but I'll be covering more horizontal in different broader aspects. So this will be my. So these also, I will be also giving some overview of my lab, because those are the things that I work on. So my lab name is Cosine Lab, and inspired by our small lab. So I have also given a name to my lab. So it's sort of this Cosine Lab is the logo. Computing for Secure and Intelligent Networks Lab. And these are the things, topics, overview of the topics that I work on. Some of my students, direct students, some of them already completed their degree. So this slide is little bit outdated, as happens with all faculties and all. So when you will go to that stage, you will also have a similar experience. Like Kimsi and Skaria have recently completed their degrees. Karun also. Other students are currently with me, and some more other students are there. So you can find all these details in my our lab website. And these are summary of our recent works and achievements. So we have these projects running by different, funded by different agents, like we had IIT Hyderabad takes in our institute. So it's all these two are EST Technology Innovation Hubs, with some other fundings that I have received previously from CDV2 as well as from Intel. These are some of the publications from my side. And the upcoming publications are actually driven by students. So all the grades should be going by the students as well. Yeah, so these are the current projects that we are running. So maybe I'll not speak with those. Yeah, so I'll be speaking more on this. So broadly, what we are seeing, what kind of changes we are seeing in the computing and networking aspect in recent times are these. So to start with, we are no, we are working mostly in the broader domain of IoT. And so IoT covers basically all these sensors and intelligent sensors we want them to be. So I have taken two different scenarios here to explain, how IoT requirements are there and how the challenges are there and how we can solve those. I'll be talking in subsequent slides. So this one is a comical take about a scenario that is a smart home scenario, and where all these different devices, they are smarter devices. So they have sensing capability as well as communication capability. So if you look at these captions, so this is a smart fridge, this is a smart oven, this is a smart Roomba type of thing, smart watering plant. So all they are collecting some information from the surrounding. So like for example, so uh, this smart plant is saying that the house smart meter is telling everyone that the scary cat, so this person, so they are name calling this person, is still using a night light. So they are gossiping about this person in general. Different other comments also you can see. So yeah, so this person is like, if he thinks he is eating less than 1,000, how much? 2,000 calories a day. Okay, so they are gossiping. So how? So but from the jokes happen. So what information are there? How much amount of calorie? How the police knows about this from the content of the food? So it has some kind of sensor from which it understands. Maybe it may be image sensor. It may be some other type of sensor from which it understands. It can have an estimate about the calorie intake of that. So similarly, so think about this comment. So this is a smart watering plant. So it has soil moisture sensor. It has like some actuator, which will flow the water, but it doesn't have the light meter and all these sensors, right? So how does it get that information? So it gets that information from the smart meter. Smart meter is some other sensor, right? So they are also communicating among themselves. So they are intelligent enough to understand that they are surrounding. They have the spatial intelligence. Okay. So they are similarly collaborating among themselves, so sharing information among themselves. So some other comments are also there. Dummy needs to test me now and then, or at least check my app. Okay. So like this person, this device is saying that okay, this person has never used this app. So now, so this I don't know what it is, smart camera or something. So don't bother with him. The previous, oh, so this is a smoke detector. So the previous smoke detector, he beat to them with a broom handle. So somehow, so so they are, also understanding one another, right? So from these comments, you can see that they are also understanding what the other sensor is saying, as if they are like different humans gossiping about another. So this is one scenario. There is another scenario. Uh, there is a smart traffic scenario. So where we have these roadside units, and some people are, so these are like like us, always glued to their phone. And they are, warning us that, okay, this is the, end of the road. One step more and you are gone. So all these different sensors show similar thing. They are also understanding the surrounding, what kind of problem it might cause, if this person takes two step ahead. Uh, so this is like alerting from, ahead that you are heading towards the what is this parking meter. So all these thing are overview is same. Yeah. From the message from these two pictures are that we have sensors. We have so typically what we have network of things. But the requirement is that we need to have network of intelligent and trusted things. So intelligent because so they need to understand their surrounding. They need to understand when to share the information. Also, when you are sharing the information, they also need to be trusted. So information we cannot share with anybody, right? So they had to share with trusted peers. They had to share when to share, how much to share. Right? Maybe this peer is trusted, but maybe you have to give only like role-based access control kind of thing. Like whatever this person needs, only that information. So future will be on focused on these two things. And so based on this motivation, I have also kept my labs focus on intelligent as well as secure things. Okay, so this is from one of my previous paper. So this shows the typical technological stack, or maybe system level stack. It's better to say system level stack. So what we have is a pyramid-like structure, hierarchical structure, where the bottom layers are focused about connectivity and network. So they are like actual sensors, they are deployed with different types of network topology. It may be star, it may be some other type of topology. So what are the things that are in the devices? So we have some smart sensors. So sensors means sensor node. So in general terms, IoT devices, maybe smart tags like passive sensors. And the upper layer is consisted of high power computing, data center and cloud. And somehow where in the middle we have edge nodes and gateway. Okay, now edge nodes and gateway, the definition is not limited to be exactly here. So sometimes maybe this can be called as a edge node, fog node. So there are different names of different types. So more or less broader aspect wise, they serve a similar purpose. But we can we define it based on different requirements. So maybe for application wise it may be different. I don't have the slide here. So maybe for say traffic type of scenario. So this type of scenario, maybe this is the edge device, or maybe this is the edge device. Here maybe we have another device which is kind of all the devices data sends the data routed through that device. That may be a gateway device, right? So application to application it may vary. But broader aspect wise, philosophically, this is the purpose. So the bottom layer was relevant to communication and connectivity and networking. Upper layer about intensive computing. And its purpose of the edge or gateway nodes are to provide faster computing. So sometimes to provide privacy aware computing. So delay aware computing, delay and privacy aware computing. Basically. So here we are collecting data. And from different spatially distributed sensors data, we have knowledge at the edge layer. And from the edge layer, broader time scale data, broader spatially distributed data set, we have what? From that knowledge, we have wisdom. Okay. So this is more or less local. This is toward this side, we have global knowledge and better model of this thing. Okay, so edge nodes, another purpose of the edge node is to keep a balance. So in life, we need balance. We have to balance between job we need to balance between, different responsibilities. So similarly, age notes are very interesting. So they talk about, balance between this workload, balance between, the requirements, balance between the quality of service. So they provide, sometimes they provide delay hour computing, sometimes they need to provide privacy hour computing. So delay hour means, so whatever, I'll not send all the data to cloud. Sometimes I have to do computing here and send the result back to the system. So let's give a small example. So mostly we have Android phones. What we say? Or other, like say, we say some keyword and the phone gets activated, right? So let's say we say, okay, Google, and the phone automatically gets activated. So what happens? So it takes the audio input, right? From our side, the audio input is taken and that is processed in the device itself, or it may be processed in the cloud itself, right? Google server. So one thing might be, if we want to do processing in the device, so device will do the speech processing, right? So there will be some model which will understand that, okay, this speech means these are the words, these are the letters or words are said in this signal. That has to be detected, right? Then we find out, okay, this was like, okay, good. So this is an activation word, so it has to be activated. Now we can do this in the device or we can do it in the cloud itself. So difference will be, if we send this audio signal to cloud, so it will take, so recording this is for a small time, but sending it will be taking more time. And then from here the reply might get more time. So here we have to use this balance. So whether doing the computation here, so to do the computation here, what we need is that the device, each device has to run that model. So it has to take the responsibility to run that model. Means you need to have enough compute power, you need to have enough battery power, right? Or if we are sending to cloud, basically we don't have to care about those limitations because edge devices are limited in terms of resources. These are not limited. So here the communication delay will be mine. So we have to take balance between this. That if we are sending to cloud, we have cost of, time taking, more time taking for sending, then processing and all. There might be, it might be going to TCP packet, so there might be one of the chunks what missing, retransmission. So all these things we have to calculate. Another is, if we are doing here, so do we have the sufficient compute or not? Sorry, do we have the sufficient resource or not? So based on that, decision is taken. So typically, these are done in the here edge device order. See, if you have told this activation keyword and it is taking 5 seconds to activate, we'll all get bored. Huh? We don't see the, beyond 5 seconds of a reel. We decide just in the 3 seconds whether to see further or not, right? So, and nowadays also, due to improvement in other technologies in the VLSI side, the phones are also quite powerful, right? In each, so Marquis law, sorry, Moore's law. So every time, there is like, so what we can say that, in the upcoming 5 years, whatever progress we have done in the last 10 years, similar impact can be done, or maybe more. So this is going, converging with very fast. So, so all this balance we have to think here, and all these different improvements in different other sectors also helping us doing the compute here itself. So similarly, we are in the 5G era. Although it's not like 5G is available throughout the country, but 5G is mostly evident. But we are going towards the 6G era, and 6G is expected to be available around, just available, not so much like 5G. 5G was when I think 21 or 22 maybe it was there, right? So 6G will be there by 2030 or maybe little later also. But here nowadays, what we are doing, we are trying to focus on what should be there in 6G, how 6G should be, yes. And so most of the things in 6G are like 5G plus plus. Means it was there in 5G, it's not new. It was there in 5G. It's just going to be better in 6G. Like delay, upper limit for delay, upper limit for the throughput. So upper limit for delay will be reduced further. That we have to reduce the maximum delay. Similarly, we have to increase the throughput, spectral efficiency. So from the same bandwidth, how much efficiently we are using that bandwidth. So that has to be improved further. So all these things are, I call it 5G++. But there are some new things that will be introduced in 6G, like say introduction of satellite. Satellites and non-terrestrial networks will be part of the normal networks. So, okay, also use of AI. So use of AI was already there in cloud. It's not immediate, right? So for these two layers, it is not so much immediate. And currently, basically, we are focusing on all these, different type of machine learning models like uh, be it reinforcement learning, be it federated learning. All these are very much relevant to this kind of problems. This kind of problems where the intersection of systems and network. Because we have all these distributed devices. So federated learning becomes a what should I say, de facto technological stack to be used in a lot of different architectures. So moving forward, so so here I'll be quickly covering a broad way the philosophical. So after Doctor of Philosophy, we have all philosophies in life. So uh, so I'll take in 4 steps. I have divided into 4 different stages. So first stage was that separate sensor network, siloed sensor networks. So what we have here, dedicated sensor nodes, dedicated for some specific set of users. They are connected to, say, internet or somehow, or dedicated private network. But this is dedicated for some specific application and some specific set of users. Second one was introduction of cloud. So instead of just dedicated one, so we have different sensor uh, networks deployed through clouds, and we call this sensor cloud. So in my PhD, I worked on this cloud. So all these networks are connected through cloud in the model of sensors as a service. So as we use electricity and all as different service, what are electricity? Similarly, sensors also you can use on device. Like say cloud provides what? Software as a service, platform as a service, infrastructure as a service. Similarly, we have sensors as a service in this model. So that so the user should be so there should be an arrow here. So the user should be not dedicated set of users. There will be multiple users, multiple applications. So so here the model was kind of one-to-one, but here the model is many-to-many. So many users, many applications to many different sensors. So maybe let's say I'll give a very small example. Let's say one user needs a temperature for some specific area and needs with some high precision, like exactly this room. So then we have to give data from let's say this sensor. And another user needs little bit broader, like this IIT area. So I can give from 2 different nodes. We can take average and all, and we can send that value. So this is 2 different like application scenario where 2 different users have 2 different requirements, and we are providing them. We are through sensors as a service, we are provisioning them to access this information. Okay. So this was in the second stage of networking. Second stage of evolution. Okay, so next stage of evolution was bringing compute to nearby this source of data. So edge computing, edge or fog computing. So cloud model is there. Edge devices are there, which provides again delay aware computing, privacy aware computing. So this is also relevant for industries, because industries they don't want their data to be shared with outside world. So they want their own dedicated edge servers, edge gateways, compute towards them. So this was the third stage of evolution, bringing compute near to this. Okay. So the next stage is where we are currently. So here It is about terrestrial and aerial. So till this point, what we have here, all these are terrestrial IoT networks. Terrestrial, terra in Latin means earth. So terrestrial means all networks to near earth. Okay, so there is also a technological definition like some 100 meters or some limit is there. Okay. So all towers and all which are based on ground. So all these are part of terrestrial network. And this is aerial or non-terrestrial part, which will be added to the terrestrial network. So merging of, so there are different names for this also. Hmm. Like terrestrial aerial computing, terrestrial non-terrestrial integration, space aerial ground integrated network or SAGIN. So some different names are there. Philosophically, they are same. So we are currently here. We are going through this evolution, and we have to whatever. So as technologists, as researchers, we have to think how we can improve this stage. Okay? So currently, my lab's focus is also here, and we have some works done centering this. So I think I have some slides for this. I'll just go through them. Okay. So so 6G I spoke little bit in the earlier slide. So here let me speak little bit more on 6G key performance indicators. So KPIs. Okay. So we have multi-dimensional key performance indicators for 6G. What are those? So here mainly we have three different dimensions. First level goal is about connecting everything. So whenever there is a new standard, so one of my colleague from another background, so maybe physics or something. So he asked me, so why you guys propose 5G, 6G, 7G? So why don't just tell NG? Uh, so why don't just propose an nth iteration of that? So we said that it's not possible to know what I need in nth iteration. So I can only just go step by step, iteratively. So now we are in 5G. So we know that okay, what are the things we can improve and what are the new things we need in this model. So that's how we come to these points, and it is divided into three different levels of goals. So first level is connecting everything. So whenever there is a new standard, so we try to add new frequency bands. Okay, new, like say some parts of the some parts of say country was not covered previously, so that has to be covered. This is the part of progress. Huh? So connecting everything is the first level of goal. By using what? So by using say different new spectrum bands. No? So 6G will add new different types of spectrum like sub 6 gigahertz, higher gigahertz like say beyond 50 terahertz level. Okay, so all these bands should be used in 6G and higher data rates. Uh, yeah, more spectral and energy efficiency. So this from also from communication perspective. So first level goal, KPI dimension one is towards first level goal. Okay. Mostly in the communication layer, physical layer and math layer. Second level goal is up to connected intelligence. No, not just connecting everything, connecting with intelligence. Okay. This is the second level goal. So how do we achieve that? So there are different points like to understand the spatial and temporal status of our scenarios, spatial and temporal scenarios, status of the resources, what is going through in other devices. So again, if I want to know everything, again I have to take some balance. If I want to know everything, so I have to do a lot of communication. That will also consume a lot of energy. So I have to again balance here, right? So capturing the spatio-temporal status of network environment at system level. So to understand that, okay, my nearby devices are at what stage, what kind of request they might send to me, how much resource I should have at different point of time. Okay. Now this device may not be stationary. If it is stationary, its neighbors are fixed. If it is mobile, more challenges are there, right? Another point is understanding the user equipment specific resource condition and utilization constraints. So from my device, previously, historically, what kind of resources I had to handle. Sorry, what kind of request I had to handle and how much resource was requested for me. So in future, what I need, I can get an estimate from that. And so this can also be again spatial and temporal wise, right? If if I am at Taxila at 10 a.m. to say 1 p.m., what may be the requirement? If I am at say guest house at so and so time, what will be the requirement? This might vary a lot. Another point which is very interesting is collaboration among all these vertical layers. You remember that pyramid picture? So collaboration among okay, this is not identical. So cloud, edge, and device. So three layers. Cloud, this edge in the middle layer, device in the last layer. So this there is also another name for this. It's called cloud edge IoT continuum. So continuum, like say, so nowadays you have this facility, right? So if I am say inside small lab, so the network 5G network is not properly, let's say, available. Hmm. Because of due restriction, like buildings and all is preventing us. So what do? We switch on the Wi-Fi. Even if we don't have the actual network, mobile network available. What we can have, we can do the calls. Calls can be continuous. It will not break down, right? So that is like a acting as a continuum. So similarly, a continuum between all these vertical layers. So how? So maybe my resource requirement is served by cloud, edge, and the device itself. So some part of the tasks are handled by device itself. Some part is offloaded to you know edge devices or some aerial devices, and some part is also going to cloud, remote server. It might be some bigger drones or satellites. So different way. And third level goal is you know finding more value from this hyper connected system. So all these systems are hyper connected means, so sometimes they have multiple connectivity. Sometimes they are like flexible with resources. So we can bring in resources as per my requirement. So to have more value or more meaning is extracted from that system. So this will be the third level goal. So here, this is relevant to handling a different scenario or different workloads. System scalability. So at different point of time, if I am having sudden, sudden change in the demands, resource demand, how do we handle that? How good I am handling those requirements, those sudden changes. So all these are relevant to the layer 3 goal or dimension 3 goals. System agility for faster orchestration. Orchestration, in orchestra, there will be a person, who is controlling the tempo of all the different instruments. So orchestration talks about rearranging ourselves with or without a central coordinator. So in orchestra, there is a central coordinator who changes, controls the tempo of all the instrument, but it may be, distributed also. No central point of control may be there. So this is about the third level users. Okay. So I typically focus, on these two dimension 2 and 3. But as per your interest, you may also consider something, which is relevant to both multiple dimensions. So that can also be a possibility. So these are some of the works, recent works. Again, this is also outdated. So some more works are there. You can see the publications from our lab website. So this is the architecture I followed in my recent research in this domain, this real terrestrial integrated network domain. So here, what we have considered that multiple drones are there, and there is a ham. So basically, they can be all called as aerial devices, not in the satellite layer. So there are in the non-terrestrial part also there are like different, based on the altitude, we have different class of devices. So satellites are typically of very high altitude, like 500 kilometers or so. I think They also have sublayers, LEO, MEO, and GEO. Low Earth orbitary, middle Earth orbitary, and geostationary. Right? So I have not considered those satellites any in their own. So I have what I have considered in the aerial layer. I have considered two different class of devices: the HAB with higher resources and the UFS with less resources. Okay, and they are also operating at different altitudes. So here our goal was, how do we handle the offloading request from the terrestrial layers in a better way. So current literature, what they focused on is that okay, either it is handled by drones or in the HABs. So typically there was no method which uh, takes into consideration a joint operation of horizontal and vertically distributed offloading pattern. What is that? Horizontal means in the same layer, and vertical means this one. So either they have considered in the vertical layers or they have considered in the horizontal layers. So in our work, specifically the work, yeah, this one published in ANTS in December 2025, and another work in ICC 2026. So these two are focused about this horizontal vertical orchestration of the user requests. And yeah, okay, so this here. And some other work is also there, which talks about this long range networks, low power long range network like LoRa or this DSME based network. How do we schedule user requests in there? So I have focused on those also. So typically they all focus on reinforcement learning. I have used to solve those things. So specifically the multi-agent version of reinforcement learning. So we have used MAPPO in solving those in this one. And here we have used federated learning along with MAPPO. So federated and reinforced both were used in this one. So so what we consider here in federated learning. So I'll just quickly summarize. So we have also considered that all this knowledge should be shared to make it a parallel and faster learning. So that was our basic goal, to use federated learning here. And I have also used some other method. I think that was like density brick clustering to locate, pinpoint the location of these drones in the user based on the user patterns. So users might not be properly distributed here. Like in reality, they are scattered. So there is no proper normal patterns like circle, box, not like that. So they will be scattered. They will be like very random patterns, like say maybe circle, but like very different type of things. So in those kind of scenarios, using dynamic clustering helps in better localizing the drones. So we have also used those. If you are interested, you can find out those works. So these are some other works that our lab is exploring. So this is basically my MSc student Kimsi worked on this setup. So we have developed a federated learning framework with low power edge nodes, with also some heterogeneity. Like there are two different types of nodes, and all the training and all is done in the distributedly in those edge nodes. So there are NVIDIA Jetsons and Raspberry Pi. So we do all training and all using the Flower framework. So here our goal was, um, application goal was, two applications we have taken. One is air quality index prediction and another is human activity recognition. So if you, so this is not yet published. So maybe you can check the archive paper. So another one. Okay. So with this, as my focus is on the resource, low resource nodes and low power networks. So typically what comes to our mind that how do we successfully run machine learning models on those challenge devices. So here, one of our student is working on this one to find, adaptive model compression techniques for this, suitable for this low resource nodes. So how do we select the proper models for for the resource constraints of the nodes at different point of time. So here we have also used the consideration of spatially and temporally distributed resource conditions that I have talked here. Remember? So user equipment specific resource condition and all. So the model compression was done adaptively based on these conditions. So here we consider, yield optimization, energy efficiency, all these things we have considered. So I think you understand that. So mostly here the goal was a balance between the actual system and adaptively how do we choose the models. So some other work that I am currently focusing on are very much buzzwords like agentic AI and digital twin. So we are doing some works with agentic AI on the non-terrestrial, terrestrial integrated scenarios, uh, of orchestration of the edge resources, this cloud edge IoT continuum. We have also used, we are also using digital twin to model agricultural scenarios, energy management in the smart building, disaster management scenarios. So all this we have done. So one of my students also worked on finding semantic compression or semantic communication in non-terrestrial terrestrial merged communication. So what we consider here is that so semantic talks about not the actual transmission of the bits. Okay. So till this point, so Shannon-based communication was about transmission of all the information bits. So semantic change the perspective. Semantic talks about not the bits, the meaning of the information. Okay, meaning of what it wanted to transmit. So instead of transmitting all full information, so we transmit only the meaning, and it should be transmitted in a way. It is like we are instead of sending 100 units of data, we are sending 5 or 10 units. So we should also have a way to expand that information, right? So it has to be again. So there are also a lot of challenges like how do you know how much to compress, how to balance between the compression ratio and the information quality. So all these are relevant problems here. This is also currently submitting about submit, so it's not the work is not publicly available. And some other work I focus on is secure metaverse and wireless powered IoT. So which I worked in my postdoc, so I try to expand that in my future works. So that was all about my work. This is my lab's location. If you want to know more about my work, this is my personal website and this is my lab's website. So thank you for your time. So any questions?
Thank you, sir. So is there any question? If you want to know more about Sir, you can visit Sir's website and you can take a snapshot of this space and you can access the website.
This is my email ID.
And if you are interested for internship, PhD, masters, you can connect with Sir also at IIT Dhanbad. And Sir mostly working, as you know, understand as you understood, like which domain Sir is working. So if you have still a question, you can ask.
So if there are no questions, basically it means 100% is understood or 0%.
Also, the interns who are working in HR are working in this
Similar topics only. Okay, so I think you find it like okay, we'll do something about this.
So, how many of you are working in the edge computing part? Can you raise your hands? Edge computing? Only few. Okay. Kritish, you are also working in the edge computing. These are all edge. And who are working with directly or with the hardwares, any kind of hardwares, IoT hardwares. So, I was saying on Mart, so already we are working in we are working on something on Mart. We have almost completed.
So there is
So
also.
we are going to submit something on that also. So thank you everyone. Yeah, and also in the like you were discussing about sensor as a service. So how he will implement this in real life?
So it was, already implemented back in that time. So sensor as a service, I think you can model it using, say we had this cloud-based architecture. We had a private cloud hosted in our system here. And what specific part you want to? Because I'm not very, I don't have any deep knowledge in this field, so like I'm just thinking sensor as a service. Suppose we have a mobile phone without camera, and camera is a sensor. So how we can implement that using that cloud, and we can click photos without having like cloud sensor. So you want to control a mobile phone remotely? No, no, like camera is a sensor. So suppose this is a phone and we don't have camera. So you want camera as a service. So like it must be deployed in some cloud system. So my mobile phone don't have the camera and I want to click photo using this phone. So how we can. So first of all, there should be a, like say dedicated app, by which you will get that service. Let's say, assume that, okay, this is available. Okay. So through that app, based on your subscription, so you might be able to choose that, okay, which locations, pictures you want. Okay. So through that you can access, and so this can be implemented maybe like say all these sensors, they are connected through cloud by their, say they will be transmitting, registered through, say their JSON formats and all transmitted to the cloud. So you know that what kind of properties are there and what are the possibilities of those sensors. So based on that, let's say, there will be dashboard from which you can choose that location. Okay. So the access should be there. And let's assume that, okay, access and all are there. So by that you can connect. I think mm, maybe you want to know about in which platform it will be implemented also, right? So that can be, so I think previously we had this Python-based services implemented in our server. I think so. Sensor is a service. Like I think you had some, you already had. But is not what I understood, like suppose there are traffic lights in the street, okay? So while controlling those traffics, they might have some camera for the traffic management. But suppose some other purposes also those cameras can be used. Suppose to track down someone, track some human. So for that purposes also we can offer that service to the police or something to get the access of the camera and they can use. So originally the purpose of camera was different, but someone else also using that same camera. No, the main essence of the sensor cloud platform is that from the dedicated set of applications, it is possible to have a many to many set of applications through that platform. Yes. Okay, and the platform also automatically regulates their access levels, automatically regulates, how much quality of information they need, at what time they will be needing. All these are controlled through one unique platform. So that was the main purpose. Okay, so assuming that, okay, this service is there. Earlier the service used to be, just one to one. Whatever service you have, you might have private services like say private clouds and all. So all these are one to one is to one service, right? So sensor clouds unifies all that in a many to many platform. Let me just add. So what is cloud? Like, so what is the benefit of cloud? Right. So in cloud, what is happening is that the same infrastructure, basically, you are virtualizing the resources and creating instances which will mimic the behavior of independent computing systems. At the back end, it's the same hardware or it's the same data center,
but you have a layer of virtualization which is creating virtual instances of the same backend hardware, giving a feeling to the end user that it's a dedicated computing system that has been offered as a service. So essentially, what are we doing? We are virtualizing the resources, right? So that we are virtualizing the same resources. So let us say that I have 5 kg of rice, right? And there are five different people.